Welcome to another video in our series called Think 6, where we discuss interesting aspects of the next generation of wireless communication, aka 6G. Today, we'll be providing an introduction of our work at Rohde and Schwarz in developing a testbed for end-to-end testing of XR use cases. A broad range of XR applications are in use today, and even more are envisioned as 5G evolves and we begin to lay the foundation for 6G. How can we begin to approach this wide application space from a test and measurement perspective? A good starting point is to ask, what are the use cases for XR? Fortunately, 3GPP has captured them in 3GPP TR 26.928. There are 7 categories, where each has a number of use cases. Rohde and Schwarz has performed an extensive internal analysis on the market relevance and complexity of these use cases from an emulation, automation, and implementation standpoint. This analysis acts as the basis of how we evaluate the application and the devices serving these use cases. When considering how to test these XR use cases, it is not sufficient to support the emulation of 3GPP XR relevant features that span across different releases and then validate their functionality and performance on a 5G modem and then simply claim XR is working. As we have learned, there are many more tools that play their part to help optimize the entire system to enable XR-based services. The details depend on the use case. So ultimately, you need to look at this from an end-to-end perspective. And that's what we did while demonstrating a prototype for a lab-based testbed to validate the performance of XR-based applications over a 5G or a Wi-Fi link. The heart of this setup is the CMX500 one-box signaling tester. Its flexible hardware and software design allows us to connect the instrument to a server, delivering services or content supporting the XR application. With our ATS 1800C chamber, we can realize an over-the-air connection towards a 5G wearable or a smartphone that would ultimately be tethered to a VR headset or AR glasses. As you can see here in the detail, the chamber has a 3D positioning system that can be equipped with an artificial head to emulate head movements and trigger, for example, re-rendering of scenes in the cloud based on this emulated pose and control information. With this testing setup, which Rohde and Schwarz demonstrated most recently at this year's Mobile World Congress in Barcelona, one can conduct an end-to-end analysis of XR use cases. Now, let's look at how to target a specific use case with our testbed. As a simple use case example, you could load a 4K video with 360-degree content onto the data application unit inside the CMX500 and stream it via the 5G connection towards the head-mounted display. You would have the option of emulating challenging RF conditions while applying fading to the signal or using the built-in capabilities to add IP impairments. These features allow the user to apply realistic network load and RF conditions while streaming immersive content to the user. For demonstration purposes, one could also capture or mirror the XR application's content on an external monitor. In conducting an actual testing scenario, you would aim to apply IP settings that mimic conditions like a lightly loaded or congested network, combined with either moderate or even cell edge RF conditions, and check the performance of the application. More advanced 3GPP XR use cases, such as an AR animated avatar call and remote rendering, can also be emulated using our testbed. We are at an initial stage of testing XR-based applications over 5G and Wi-Fi. At the end of the day, it is important to analyze the targeted use cases, determine what can be emulated, and how to test the performance of these scenarios based on well-known key performance indicators, such as throughput and latency, but also working with customers and industry partners to identify new KPIs that help to assess application performance. Due to the flexibility and the different configuration and combination possibilities of features within the 5G standard, along with additional tools and features on top of that. Automation is key. This includes automating the configuration of 5G network emulation, cloud settings, use case emulation, device control, and KPI collection. Now, I would like to summarize our discussion on testing XR use cases from an end-to-end perspective with key takeaways. First, 3GPP has captured 23 use cases organized into 7 categories. For each category, different requirements apply, thus demanding different test strategies. Testing XR use cases from an end-to-end perspective is essential, and verifying 5G and 5G advanced features alone is not sufficient. Our XR testbed, based on the RNS CMX500, provides a lab-based approach to understand the end-to-end performance of XR use cases, which is key to success from both an end user and consumer perspective. The XR testbed can be fully automated, including configuring 5G network emulation, server settings, XR use case emulation, device control, and KPI collection. To conclude, it is important to emphasize that for 6G, several new disruptive technology components must be mastered, as they provide the building blocks to fully enable applications like the metaverse. No one can do it alone, and test and measurement will play a vital role in this process. I hope you are as excited as we are about the metaverse fueled by XR applications and how to validate their performance over 5G and Wi-Fi. This ends our introduction to testing XR use cases from an end-to-end perspective. Thank you for joining us, and stay tuned.